Hey everybody, it's Mr. H. This video will serve as an introduction to square roots. This is purely introductory. There won't be anything in this video about simplifying or adding and subtracting. This is just for those who need a quick refresher on kind of what a square root is and what the parts of a square root are. So if you look on the screen here, you'll see that I have some of the key vocabulary laid out, and all of these terms are important. If you don't understand what these mean, you'll have a hard time understanding what's going on in the lessons. And just as a friendly reminder, if you are a student, you should be taking notes here because you're going to need all of this information. So oftentimes with vocabulary, you're just given the vocab word and you sort of write out the definition. I don't think that's particularly helpful, really in general, and certainly not here. So I've decided to sort of give you a walkthrough of a scenario, and I will highlight the vocab words as we go. So consider the following scenario where you're given a set of instructions to follow. So imagine that we think about the natural numbers. So our first step is going to be pick a natural number. If you're not familiar with the different types of numbers, that's okay. There are numerous classifications, but when we talk about natural numbers, we're talking about the counting numbers. And your counting numbers, you can kind of think of it as it's natural to count on your fingers. So the counting numbers are what you can start counting on your fingers. So 1, 2, 3, 4, 5, and so on. 0 is not included in there. In this particular case, we need a natural number, and we want it to be less than 10. To clarify, 10 is a natural number, but we need something smaller than that. I'm going to pick 5. Now, if I tell you to take the number that you just picked, you don't have to pick 5. You can pick a different number. But if I tell you to pick that number and square it, in this particular case, I'm not talking about square as in the shape. I'm talking about squaring in terms of actually exponents. So square the number, referring to that 5 up there. What that actually means is to take that number and multiply it by itself. So anytime you see find the square of a number, we're saying 5 times 5 in this case, because that's the number 5 times itself, and we would get 25. Now, oftentimes in algebra, what we will wind up doing is, instead of saying 5 times 5 is 25, we will actually say 5 squared equals 25. So there's a couple things going on here. First, I'm just going to kind of do a little asterisk over here. Squaring means to multiply a number by itself. This example here introduces the idea of exponents, though. So whenever we say squaring, multiplying a number by itself, it turns out that exponents actually tell us to do that as well. So like in this case, 5 is your base, and 2 is your exponent. So literally that means that if you see an exponent of 2, like we have here, that is saying I am multiplying 5 together twice. In other words, I'm going to multiply and I should have 2 5s. If that was to the third power, it'd be 5 times 5 times 5. So just to recap, we picked a natural number, we squared the number. We figured out that if we pick the number 5 and we square it, we get 25. Again, you could pick a different number, but it could be written either one of these ways. We're still technically on what I called step 2. It was just on the previous page. So don't let this confuse you. It's just 2 different ways to write it, and most of the time in algebra we start using exponents because it condenses it and makes it take up less space. It's easier to write. Alright, so if I tell you now in the third step, in this scenario, think about the product that we just got. So if I say think about the product, essentially I'm meaning, what is it? And I want to clarify here, I don't mean a product as in like something that a company is producing. That is a definition of product, or something that you buy at a store. In this case, I'm talking about what you get as the answer to a multiplication problem. So in this case, 25 is our product. Now, next step in our scenario, what if I told you to take the square root of the number we just found that we said is the product? Well, I'd be telling you to take the square root, again, of that number there. So how do we do that? How do we take a square root? The syntax, the math symbols that we would use are this. Well, is that? That's a square root. It's a radical. Square root of 25 equals, well, what's the square root? What is a square root? So I think the easiest way to think about it, if you're not familiar, is that when we find the square root of a number, we are undoing the squaring process. So in other words, if I go back up here, since 5 squared equals 25, it follows that the square root of 25 has to be 5. These are just, we actually call them inverse operations. Similarly, you can think of them as opposites. The better word to use is inverse. So if 5 squared is 25, the square root of 25 must then be 5. In addition to understanding what square root means, you need to understand that there's actually some terminology used when we throw that symbol in there that I use. So that radical sign that looks something like that, that's called a radical. And whatever number I choose to put in here, whatever number you put under it, we had a 25. So I'll use a different color just to illustrate. So we had 25. In that case, 25 is the radicand. That's just the word that we use for it. So radicand just refers to whatever number you put under the radical. And last but not least, just in our quick little review here, is the idea of perfect squares. It's important to remember when working with radicals. A number is called a perfect square when the square root of the number is a natural number. So like, that's a perfect square because the square root of 25 is 5. It's a good idea to know the first 12. At least you should memorize the first 12, and the first 12 I'll just list them out here for you. It's 1 and 144, and they keep going. That's not an exhaustive list. It just keeps going on forever, actually. The reason why those are perfect squares is because if you take the square root of one of them, you get a natural number. So what I mean by that is, like, the square root of 4 is 2. The square root of 16 is 4. The square root of 25 is 5. And so on. Every single one of these, you can take the square root and you get a nice number. It's like this 144. The square root of 144 is 12. And what I mean by you get a nice number, you get a positive number that is one of our counting numbers. So you don't have to worry about any kind of decimal.